In this lesson, we focus on the issue of poor initialization of centroids in the k-means clustering. We will start with a couple of examples that show how poor initialization in k-means results in low-quality clusters, and then go over the k-means plus method, which is a variation of k-means that addresses this initialization problem. This example shows what would happen when the initialization is not ideal. We start with the same dataset, but this time we select a different set of k centroids. Everything else in the algorithm stays the same: assign the points, recompute the clusters, and repeat. But because of this initial choice, this run of k-means ended up with poor quality clustering. The clusters may not make intuitive sense, or maybe one centroid might get stuck covering too many points. Another example, suppose we have a dataset that consists of 4 points. Notice how the choice of the centroids grouped 1 and 2 together and grouped 3 and 4 together. However, it turned out that 1 and 3 is closer and 2 and 4 are closer and should be grouped as clusters. The k-means method changes the way centroids are initialized. The first centroid is selected at random as before, but the next centroid is selected from one of the farthest points from the currently selected centroid. And to achieve this goal, it computes a weighted probability score based on the squared distance between the first centroid and all of other points. In other words, it tries to assign low probability to nearby points and assign higher probability to distant points. Note, it didn't try to pick the farthest point blindly, because this would end up picking an outlier. Instead, it approached the problem by introducing randomness in a smart, distant weighted way. So points close to existing centroids have a low probability to be chosen, while the ones that are far away have a higher probability. So this randomness element makes the method more robust and leads to better clustering results on average. In summary, we discussed the problem of poor initialization in the k-means method.